First, I apologize for the title. I'm sorry. It's hard. So let me start with a little stories that you know, that you've lived probably in your life, like take random systems, like a credit loan system, and it starts with the submitted stage, and there under review, approved, and then funded, hopefully. And sometimes it will end up denied, right? That's the status of your loan application. And sometimes you have another system, like a distributed system for distribution system, for selling stuff, and it starts with your order is placed, and then it's confirmed, and then it's prepared, and then it's shipped, hopefully, and sometimes it will end up canceled. All right? And it starts like that, always, everywhere. But at some point in time, look what we've done. Statuses, a lot of statuses. See here? Oh my God, 29 of them. Wow, and the last one is manually managed. Wow, oh my God, cancellation. No, you're laughing because you've seen it before, right? Cancelled but not refunded. Oh my God, refunded but not cancelled. Wow. How did we end up like that? Oh, look, there's a new one. That's the answer, actually. We ended up like that, one at a time. Okay? Like everything. So now, the people I meet at various companies, we are trying to split this big system into bounded context. But the bounded context say, no, we are too coupled, they say. And the customers don't have a lot of problems like that. How do we untangle our contexts that are coupled because of this causality everywhere? Help! And so the big idea in this talk is to go through ideas on how to deal with that. And the big idea is we should handle everything time-related in a way that aligns with its natural flow and direction. All right, so I'm Cyrille Martraire from Arolla. I'm a co-founder of Arolla and a CTO of it. I have many colleagues there. You can recognize us with this green jacket. We are very green everywhere in everything we do, and we are big fans of everything DD. TDD, BDD, DDD. We love everything architecture as well. We apply craft to architectures, and we can help us. You can help you with trainings, consulting projects, and I've been asked that we need to say that we are Calliope. It's very important, apparently, in France. Private jokes, you have to do that as well if you give trainings. Buy my books as well, and our books, we are there, we can sign them, my colleagues and co-authors are there. All right, coming back to the topic. No, e-commerce, at first glance, is not that complicated. It's just a couple of statuses. It's just a matter of items that you need to take from warehouses and give to customers at the end. It's not that complicated. But for real, if we look inside, and for real, we should be able to represent the full thing with just that. And my colleague Christian calls that workflow as one field. And it's true that many systems are done like that. You agree? We do that a lot. And this field decides what to do next, very often. But e-commerce, for real, means a lot of people taking care of your orders and everything that can go wrong with it. It means a lot of items, average items, standard items are there, and there. Actually, it's very complicated. And small stuff are separated into smaller cells in the warehouse. Heavy stuff is somewhere else. And sometimes with this machine, you can get one and crash it on the floor. You destroy the item at the time you prepare it. Actually, everywhere, things could go wrong. The thing you thought should be there wasn't there. It's out of stock, apparently. We didn't know. And then you go to packing, and you try to put the things inside the box. But in between, things could get lost in transit, could get lost during shipping or before shipping. And things disappear, and they reappear sometime later. Oh, why this item is there? So even the packing area may be a storage that you don't know. And then shipping, and you have to put the right box into the right truck. Otherwise, and things happen as well. And returns, and invoicing, and even invoicing can go wrong. That's real life. So basically, you know that, and so because it's hard, you need experts, and you have multiple teams being very good at doing all of these. And talking about domain-driven design, they probably would end up with their own languages, each of them, they would end up in different bandit contexts, different pieces of code, different domain experts related to them. So in real life, you have some prerequisites. You cannot pack stuff unless you have it. And to have it, usually you get it from picking. That's not the only way. And to ship, you have to pack. And that's how you would talk about the problem from the first principles. So we end up with a distributed process like that, where you have things that happen after something, and also as a result. And this thing, the full thing, here you see the flow of time flowing from the left to the right. And it flows actually from the cause, one cause, typically, to consequences. And the consequences, you have many of them, multiple consequences. And that's one thing I found very interesting, is that as you go through the consequences, they multiply. They multiply. And you end up with some kind of explosion of consequences. If we zoom inside the bandit context, for instance, we can start with one purchase order, and it becomes two preparations order, because you have to pick items from this warehouse and from this one, which are different. So you split the preparation orders by hub. And then one item is not available, and we have to wait for 1 week. So we ship what we have, and we will ship the rest later on. Real stuff, right? And so now we end up with multiple stuff with multiple shipping orders. Make sense so far? Yeah? The opposite can happen as well. Sometimes you group, you merge stuff. You have two purchase orders in the same day, boom, or on the marketplace, they're going to be paid as one. And even the payment can be split again. You pay by voucher and then your credit card. So it's very interesting to see that typically we end up with something that starts simple, doesn't end simple. And I think we have to see that and accept it, because that's one of the challenges we have to face. And this is totally related to the causality thing. So what's causality? You know it. It refers to the way actions or events can trigger consequences somewhere else. And here, because we are talking domain-driven design, we are talking from one bandit context to many others, and again, and again. And so to me, it's like a causal tree or DAG. Anyone familiar with DAG? Yeah. Directed acyclic graph. It's like a tree, except that you see that this node has two parents. So it's a tree with some recombination. It's not very complicated. It's just a more general kind of tree. Nothing fancy. And this thing is distributed. So we have a kind of distributed composite there. And so the metaphor is the waterfall. Waterfall is no longer in fashion. And you see, so that's a very pretty picture. Let's screw the picture with the causality metaphor. You see one cause, and then blam, 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 blam. It ends up with multiple streams of water. And it gets even worse than that. The full thing doesn't propagate instantly. It takes time. Here, we are waiting for someone to complete the job. Who? Now, at the same time, something else is happening. So we have parallelism there. And by the way, every transformation, every digital transformation these days, we don't say the word anymore, but we do it anyway. He's about to flatten this so that more happens in parallel, right? To reduce the time to completion. So we want parallelism as well. But what it means is we're gonna wait to multiple stuff, and it's gonna be, the timing gonna be shuffled, gonna be random, arbitrary. We are always waiting for something. And we may also end up with complete success or just partial success. It's not even binary. Overall, it gets increasingly messy. And all these things, they combine against us to fuel what we overall call entropy. And entropy is your business process. You start simple, easy to understand, easy to reason about, and you end up with, oh my God. So, you know, in science, we usually say that entropy is the arrow of time. Why? Because if I show you these two states, which one most likely comes after the other? You know, they go like that. Usually, the disorder comes after. It's very unlikely. It takes a lot of energy to do the other way around. Just like this as well. Plom, plom. Walls usually don't build themselves, but they can collapse themselves. And our systems are just the same. So it's hard, but we have to accept that that's the game, and don't even try to fight that. It's like the Conway's law. Don't even try to, it's stronger than you are. So don't try to go backward. I could stop there, and I think I would have shared the big idea already. Try to go with the flow as much as you can, and the rest is how can we do that? It's all about these causality patterns. So actually, we are with some colleagues and friends, we are trying to express more of these patterns. It's a work in progress. And so here we're going to share some of them, starting with the easy ones. So now imagine you place the order, or you start with, you place the order. The order has the identifier 1, 2, 3. And you can commit it. Your transaction is done. It's done. And now, so far, it doesn't, for some time, it won't change. But the consequences we're going to get created. So, for instance, you have the propulsion order and the invoicing order, maybe, for the invoice to be generated. And so you create new entities, and you commit them in their own DB. And the way you do it is you make sure that the consequences reference their cause. So, for instance, the force 5.6 here says, I come from 1, 2, 3. And they can do that directly in their own commit in one way, so they can all be immutable so far. You see, that's the beauty of the thing. If you go with the time, you can always have immutable stuff. You don't have to change them. However, and that's where, and you can do on, and so on, and so on, and so on. But where stuff starts to get very bad for you, and that you should not do, if you try to do the other one. You start with the initial creation, you create the consequences, and then, as we usually do in a DB, for convenience, we want links from the orders to the tracking ID, to the shipment ID, to the invoice ID. And this convenience is not convenience. Why? Because now you have to accidentally, to artificially, to the very undesirable way, you have to mutate the order, even though the order did not change. But technically, you're going to change it and hack that to be convenient. So immutability is great, is nice. Mutability is OK sometimes, but mutability for bad reasons, no. You're with me on this one? So, yeah. Concluding this thing, go make sure that the future references the past, not the other way around. In real life, it's hard to do anyway. We can only do that in our systems. So coming back to the status of our orders, the workflow as one field should go like this. And by the way, this workflow assumes that the process always flows the same way. From place to confirmed, to prepared, to shipped. And this process, so actually the process is distributed, as we've said, and started at each point, in each bounded context. They all have work to do, and they start from I have to do something to trying to make it done. And they do the same, each with their own expertise. So the process is distributed. If we look at the local states in each of these 6 bounded contexts, and 6 bounded context is a small-ish kind of system these days, we go through the various states like placed, reserved, authorized, captured. We get the fonts for real. And then pending, prepared. As soon as it's prepared, you can maybe start shipping. That's just an example of a flow. And now we say we are done. It's just one indicative flow anyway, because the real possible states of the systems are, you see it? They are just all the Cartesian, all the combinations of these local states theoretically could exist. And at this point, you could say, yeah, but Cyrille, most of these states are just impossible. Yeah, they are impossible until they arrive. Real life is messy, they arrive. So even impossible states happen by mistakes, and you end up with actually thousands of possible states. In real systems, it's more than that. So forget about describing everything with one field that you, as a workflow, by the way. So what does it mean? It means that if you have a status in your T_order table, like you have, I can pretty bet on that, then this status is changing all the time, not because of the order, but because the order did not change, but it's changing because of everything else in the system and in the world. Even sometimes it even changes because of your partners, external to your companies. The state didn't change. So we again have a case of accidental mutation. Accidental is the keyword. It means that you could avoid it. It's not fundamentally, essentially necessary to have it. You could do without it. So now for the big picture of it all. Sorry for the picture, but I like it anyway. You see all my context there with their local states. And then if you try to mix it up into a big list of statuses, it keeps on growing because you keep on going through this order status. Actually, it's not about the order itself. It's about the state of the full system. And you keep on adding new statuses because you are just trying to do the Cartesian product of all the local states. Do you like the diagram? Don't show it to your colleagues, please. And that's how you end up with the manually managed one. This one means every other that we did not dare put into the system yet. And it also means support stuff for real people in the customer support team, right? So the customer on their side, they say, hey, what's the state of my order, right? And they are right. They need to know. And the real answer is the state is just a bit there, and there. Thank you very much. No, you can't say that. We want something better. We want to pay attention to the customer experience. So what we do is, yes, we need to create a status, the overall states, summarizing the state of everything. But this thinking is just UX. All right? It's a UX thinking. So yesterday, Alberto mentioned the surface language, the language that you share to the rest of the world. That's what we are thinking about here. The status, if there is one status, actually, it's the status that you show to people, and it's an invention that fits the mental models of your customers, and that hides a lot of your internal complexity. And that's something we need to do. So even if you wanted to keep the status in your order, the right way to think about it properly would say that this column is special. This column is a read model for the intermediation with the audience, and it's a read model for something that actually where the source of truth is everywhere else. You could feed it, you could complete, and actually this would be the truth table to compute this status, something like that. Yeah? The diagonal is the nominal case, and every anomaly, boom, you would summarize with, hey, you should call the support. And so that's the way it goes. So it's kind of going macro and micro at the same time. So that's the other thing, and an obvious one. And now, what about cancellation? So canceling, imagine we started something and in process, mid-process, we want to cancel. Boom. So we are here, 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 and here in the system. Some stuff is completed, some is not. Canceling would mean reverting from where we are and going backward in time. Doesn't look very good. So most of the time, the real companies do it using Saga and orchestrators, and it works. And the way it works is you have a nominal case with a complete set of transitions, and you are kind of trying to pretend this thing is linear or with forks and join, and you also have the compensation from where you are back to the initial, so trying to compensate from where you are. And it shows on the diagram, we kind of have to double maintain the two cases. And in real life, actually, we can have many more transitions than that. And that's because the process is making, the entropy is hard, as I said. So don't even try to fight it, go with the flow. What if we could undo using the same flow as doing? So trying to frame undoing as a special case of doing. I know it can sound a bit weird. Actually, it sounds like this. Canceling an order for an item, what if you would consider it as a special, as a way of just ordering an anti-item, right? That's stupid? That at first look, when I say that, people laugh. That's true. But actually, I mean it really. I know that sometimes to make it true, you have to go through a lot of extra thinking. I don't have the time here, but actually, it's more common. It's more common. You can do that more commonly than you think. Like think about storing and moving code and data, like logistics of data, stuff that Kubernetes is doing, that Puppet, Terraform is doing. They are taking bits from this place and they are make sure that the bits are somewhere else and in a different state. They do these kind of things. Moving money and everything can be fungible, like financial instruments. If you want to cancel a financial swap, you can really buy the anti-swap. It works. Same for a lot of stuff can be like this. You can have the thing and the anti-thing, and it works, and the end result is nothing. Promise as well. Promises are kind of thing like this, like when you book hotel or train, when you book a medical appointment, cancellation is still distributed in a lot of places, but you can do the anti-thing, and you can make it work. It takes some twisted thinking sometimes, but it works, and it makes the full thing simpler. So basically, the idea is that if the local doing is like this, we want to do it the other way around, like that. Oof. Okay? No? That's a bit abstract, yeah, for sure, but I'm just trying to excite you to try things like that, and because it can make things, you can use the symmetry of the doing and the undoing, and you can also best rely on the local expertise of each context to do and undo and decide locally what's best to undo, because they are the experts there. So they are the experts of what state they are in, but they are also the experts of how best to revert. And so actually, of course, we could spend 3 hours going into how to do this in details, but what about amending? And again, we could have this causal symmetry, this symmetry of causality. What if changing orders was just a special case of doing another order? And so again, I mentioned them already, but Terraform and Puppet, they are smart in this way. You are familiar with the word declarative, I guess, here. And what it means is instead of saying, I want this process up and running on this machine, you say that instead of saying, we need to move the package there, do this, and then, and that, and then, and that. And Terraform and Puppet, the way they work is called declarative approach. And the way they work is you say, I want this process up and running there. And the Puppet will gonna look at the machine and say, hey, the process is already up and running there, so I'm done. Or it could say, hey, there's already the process, but it's not running. And then it will just start it up. Or there's nothing, and it will say, oh, I need to pull it first and then start it up. Or maybe the version is wrong, and then it would just remove and install the new one. So you see the thing, what the key approach is that they do a diff between what you have and what you want. And based on that, you, on the fly, decide what's best to be done. That's a powerful idea. And how could we apply that to maybe warehouses? We could say that, actually, I don't want picking. I just want this item. I don't care where it is right now. I want the item on the packing table. And then the picking bounded context would say, hey, I know how to do it. It's called the picking task. And they're going to do it. And now you get what you want. You have what you want. And actually, regardless of the way you do it. And now if you want to undo it, actually, you don't want to undo the picking request. You want to undo. You want the item not to be on the table anymore and to be where it should be. Boom. A lot of things can be, it's just a request like any other request. And declarative approach has the benefit that there's no arrow of time moving from left to right or right to left, from your house to the warehouse or to the warehouse to your house. It's just moving. It's not that simple, but it's convenient to see like this. And so in practice, imagine that you have an order with these 3 items, with these 3 line items in it. And now you have a new one, you have a new order, a new version of your order with 1 more line. I think you get the idea. It's very easy to diff. We are already processing this. We already processed that. It's ready to ship. And now we just have to get this from the shelves and add it to the pack. And now we can ship. And that's the idea of diffing. And sorry for that, but in mathematics, that's what we call a group, a theory of groups, which is just monoids plus the inverse, the subtraction, basically. Yeah, I said it. Monoids everywhere. So declarative, goal-driven, and group theory, they go very well in mind to help you get very close to this idea. You can do it. It's sometimes it can be heretical in your company, but you can try to get close to that. All right, one more pattern. This one is obvious and should be obvious for everyone. Just so I go quickly through it. Is very often when the ordering has to collect all the shipping data, payment, and invoicing information so that we can invoice you later. But we have to do it in the ordering because it's on the same screen. Is that a good reason to put it all through the ordering? That it's on the same screen as the ordering screen? No. No, because now the ordering screen has to distribute to everyone, and we end up with something brittle. Because every time payment has to, hey, we need one more field. They have to ask ordering to put the extra field and to do it on the UI as well. And so the answer, is the microservices should be done like that as a default style, is that it's on the same screen, but we directly store the stuff where it should be used. Everybody does that, right? I don't know why I'm talking about this right now. And so the funny thing, and it's not the funny thing actually, is I think one reason we don't do it more is that we have to commit the transactions everywhere using some temporary ID that's probably a UID. It's not yet the order ID because the order does not exist yet, at this stage. And that's the trick. And when you place the order, what you actually do is just trigger the full processing. But the data are already there, waiting to be triggered. So far, so good. The reason I think, and you get the benefits of localized change. Now, if you want to make changes, they are decoupled. So you get the autonomy of your teams there. But the reason many people don't want to do that, they resist it very, very much, is that what if we don't go to the end of the ordering? What if we abandon the wannabe order in between? Then we end up with orphan commits in multiple places. Is that a serious problem in 2024? I'm just asking. I'm just asking. I have an opinion anyway. Accept orphan entities, that's all. US memory. So there was a word composite in that.
Hi. Hello, friends. Let's talk about composites. Let's talk about the love of composites. Oh, so I don't know if it's clear to everybody, and I'm making the bet that it's not clear to a lot of people, that Cyrille just described at a very high level composites, right? You all saw that, right? No, okay. So Cyrille was describing a dire need for being able to communicate to every part of a larger system across several other contexts, having some form of way of communicating where you don't know who you're talking with and where you're spending messages and sending those messages in a way that you can have an uniformity of interface, right? And that's what we're doing with composites. So we can talk about them now. We can talk about them now because the hype on the Gang of Four patterns has died. So we can talk peacefully about this. We now can enjoy them. It is time. Let's do this. So I'm zooming in. Like Cyrille talked about composites in a very, very high level, and I was just going back to a single class, or a group of classes together, and going there with you, okay? Let's do this. Okay. So composites are about talking about the way, what you want, communicating deeply what you want, what you really, really want to classes, right? Instead of telling them, do this, you're asking them, I want this to happen, right? That's the most important part.
I forgot to introduce you, Romeo.
Right.
So Romeo Moura, he's now at version 4, I think, of Romeo Moura. Romeo as a service.
42.
we are both as a service, by the way.
Yes.
You can hire us.
Yes.
And we are also former colleagues. So yeah, yes. It's all about the composite. And let's carry on.
So composites. There is a structural pattern, right? We are trying to draw structure in the code itself. It's a very lazy way of saying this, very gross oversimplification. I'm trying to communicate with every part of the system, every part of a class, let's not say system, let's just like every part of something I'm creating, using a unified interface. So I'm trying to say the same message to everybody and not care about what I'm saying. Not caring about what I'm saying, not caring about who I'm talking with, right? That's the heart of it, right? In order to do that, we have to accept a pain, a very painful thing. Are you ready? Let's go there. We have to accept that a kebab is a kebab, but also that a tomato is a kebab, and also that a piece of meat is a kebab, and also that lettuce is a kebab. Are you ready to accept that in your heart? Maybe part of you are resisting this right now, right? Part of you will say, like, look at this and say, no, Romeo, this is wrong.
No, this is wrong.
This is dirty. I do not conceptually am ready to accept the truth about tomatoes being kebabs. So let's go there. Let's go there, philosophically speaking. I have 3 things to help you here. One is just one thing that helped me in my life, and I hope helps you in yours. Ontology leads to madness. Right? Don't go there. Run. Ontology leads to madness. Okay, that's just a gift. Let's go. Let's continue. A kebab work as a metonymy. When I say my car, you understand it. If I point to my car and say my wheels, you also get it, right? It makes sense. That's a metonymy, a figure of speech. Can we accept that figure of speech? Yes? Are you okay with that? Okay. But metonymies will be very important for the composite pattern. So I'm going back to this later. I'll give you another, I know, deep down, you still don't want to accept that a tomato is a kebab. So I want you to understand tomatoes in the context of kebabs. Yes? When you are eating a kebab, eating a sandwich, and the last small piece of that sandwich is a tomato, you are still eating a sandwich. Are you ready to accept that?
Actually, just in the context of eating the kebab, yes, the relationship with your kebab and the tomato is the same. You are just eating something that is edible.
Right. So you eating edibles are not a very important thing to do in life. So the composite is abstracting away, is encapsulating this idea of singular in plurals. Quantity is no longer your problem.
Oh, this reminds me something there. In 2005 or 6, that's probably one of my first blogs posts, I used to have this situation. I had an instrument with one currency and some instruments and multiple currencies. And so we ended up with if statements like if and calling the singular method and otherwise calling the multi-currency method. And so one way to make this uniform would be to say that every instrument has a set of currencies, even the majority of those that only have one. But this one is brutal. I prefer something more like this, deciding that my method is in currency, you pass the currency, and it says yes or no. And this one can work on a composite, regardless if you have 1, 2, or any number of currencies. You see the thing? You have to reframe the way you look at the problem so that it is uniform, singular, and plural.
You're trying to ask questions about what you want, that describe what you want in a way that you don't care about the structure of who are you talking with, right? If a tomato is a kebab, if a tomato and a salad are a kebab, a tomato and a salad and a bread are a kebab, you're always speaking to kebabs, right? You don't care about the structure itself. It is encapsulated away from you. Are we cool with that? Any of you still resisting this inside of you? Because then we will block away. Let's, right? No? Okay. Like accepting this in your heart. It leads to beautiful code like this. I would not do this in real life, right? But it leads like to being able to create a chaining of parts that creates a whole. Oh, damn, it's last 5 minutes. Oh, I have to rush this. Creates a whole, and that whole has the behavior you're looking for, and that whole changes over time. You're putting that the chaining in the structure itself. Just pass the slides, friend. We have not a lot of time. Of course,
I think you wanted to talk. Manuel mentioned that composite for you is.
Yes. Let's just go back one. In real life, like yes. Okay, composite is like encapsulating a transversal. This, in real life, we will of course probably use a list of things like that, but then we are from the outside looking at inside the structure and manipulating it, right? And for a small thing like that, of course I will do that. I'm talking about in bigger ways. I just try to communicate and not know about the structure itself. Like this ignorance of the structure, this erasure of the structure is all the appeal of composite. Because, and then we can go to the next slide, which is, because composite is encapsulating the transversal of the structure. It's encapsulating away what is the path we are taking in our dependencies.
There's a pedantic word for it, is
Illomorphism.
Illomorphism.
So that's the very pedantic mathematical word for it. Being completely neutral to what are the structures we have in front of us.
So in practice, if you have this kind of structures, the traversals could be like this: depth first search, breadth first search, topological sort. Anyone familiar with topological sort, by the way? Yeah, we are with you.
And then this creates a difference between an internal and external traversal, like between I know what is the structure of dependencies of the thing I'm looking into and try to sort into it and choose everyone and filter myself and know what I keep, versus I just say, I want this, and that traversal remains, right?
So that's things we used to learn in the past using recursive function calls, iterator, visitor patterns. We no longer do that. We should. We still have rooms. But what we do instead right now, internal, external, is hard-coded service calls or orchestration from the outside, triggering everything. And in the middle, you could do both with the something choreography, I think.
Of course, yes. Of course, the order impacts behavior, right? The difference between paying a restaurant before you eat or after you eat, that can be encoded in the order itself, and that can be encapsulated away when you talk with it. And decorators also happen, so you can decide to add different kinds of behaviors inside the composite itself. That's the whole gist of composite in very short terms.
So in other words, thank you, Romeo, for let's be explicit. The big ideas that you mentioned here is composite. It's all about the unified interface and the choice of the traversal that can be decided once and for all inside, or that we can keep flexible on the outside, or something in between. So you love composite?
I love composite.
I love it too.
I love composite.
So in closing, thank you to our reviewers at Arolla, my colleagues. And then, if you want to go further, then just learn how to survive a nuclear attack. And then, by order of decreasing importance, learn the composite pattern again and again. And then, learn about topological sort. This can change your life, if you don't know it already. And then, if you want to practice, you have the Romeo's kata, the kebab kata, which is with having composite inside, and the monoid kata, which is the same, but on monoids. And so, as a conclusion, together, 20 years ago, complexity came into the title of a book that became popular. And you know, we live in the age of complexity. We live in the soup of complexity. And we have to get good at complexity thinking because it's our new operating systems. And so it's all about safe-to-fail probes. It basically is not engineering as we know it.
It's the new engineering.
It's the new engineering. So we have to promote complexity thinking. Yet, that's the funny bit, we still have a lot of complicated sub-problems on our daily lives. There, and there. And what does it mean? It means that there we could apply good practices, solutions, solve problems, as long as we know the state of the art there, graph theory, etc. And the thing is, mislabeling everything as complex, whereas it's complicated, is sad panda again. It's lost opportunities, suboptimal solutions, lack of time, waste of resources.
And mechanistic thinking is still possible in a lot of little slices of life in the sea of complexity.
We still need that, because we are cyborg, as you said, organic thinking plus mechanistic thinking.
We need both. So there is this relaxing joy of complicated problems in this everlasting sea of complexity.
Yeah. We should approach, and so coming back, closing on the title of the talk, we should approach and handle time in a way that aligns with this natural flow and direction, and not trying to reverse all the cardinality of the consequences, or not too much. In other words, you should pet the dog in the direction of the coat. Otherwise, it's gonna get bitey, and it's gonna bite you. So, yeah, that's it. Thank you very much, everyone.
Thank you.